As you know, this meeting is recorded and will be uploaded to public internet. With that, let's start the meeting. We have a few items on the agenda, I believe. Aldo, did you add the first couple of items to the agenda?
Yes.
Maybe you want to talk a little bit about them and tell us what they are about.
Sure. So my main concern here is how do we plan to fit both the interport affinity and the event pod spreading within the framework? I think we can define a general. We can define which interfaces we want to implement.
Mm-hmm.
Which ones are the most appropriate.
Okay.
There's two sets of, well, it's two problems because it's both an X predicate and an X priority. So now we need to fit it in several interfaces, right?
Correct. Yes, that's correct. And that's fine, actually. In fact, one plugin can implement multiple interfaces. That's definitely an option. The other thing is that we have a plugin context, which is a generic sort of storage inside the scheduler or inside the scheduling framework that allows various plugins at different stages of scheduling to communicate with one another or share some data with one another. So if, for example, we go and pre-process some information in the cluster, similar to what our current metadata does for like predicates or priority functions, we can store that metadata in the plugin context and then pass them. Scheduling framework actually passes the plugin context to all the plugins, so they can go to plugin context and retrieve their data. This can be used for example, metadata or some pre-processed data that some of these plugins may want to share with one another. So that's some of the tools that we have at our disposal to make it possible to efficiently run some of these plugins similar to priority, similar to pod affinity or even pod spreading to share data, and they don't need to repeat processing some information in the cluster. So that's one aspect of it, which is mostly about like performance. The other aspect of having affinity and anti-affinity along with the event pod spreading is the API and user experience. So today, priority side of anti-affinity or interpod anti-affinity kind of collides and overlaps with the non-required version of event pod spreading, basically with soft spreading. So they are pretty much doing the same thing. Ray, please correct me if I'm wrong, but my impression is that both of the two are pretty much the same thing.
Yeah, almost. And the data structure was almost same. We should count how many paths are matched on the token node. And the little difference here is that in the priority, even pod spread priority, we don't count the minimum match. We just count how exact number of matching. Because right now the priority algorithm doesn't take the max skew value into account. So we just compare the number, the concrete number of matching paths there. So the less matching number there, the more score it has. So it's basically the current priority algorithm.
Yes. That's correct. So basically, anti-affinity is equivalent to, if the interpod anti-affinity, so priority version of interpod anti-affinity, or in other words, soft interpod anti-affinity, is the same as even pod spreading when max Q is 1, right? Basically, that's if max Q is 1, you want to spread pods very much evenly among all the failure domains, and that's what the priority version of interpod anti-affinity does. So they are pretty much achieving the same goal. Of course, even pod spreading provides more ways of setting different max skew for clusters. In that case, I guess, as we also said, min and max come into the picture, and we can have different scores for zones, so where the number of differences between basically the difference between the number of pods in one zone versus the other, or generally in one failure domain versus the other, is not exactly 1. So, but anyhow, these two are more or less the same, and they could be confusing to users. We have been aware of this fact, and from the very beginning, we actually wanted to reduce the scope of interpod anti-affinity and limit it to only 2 nodes, basically. That was the plan in the beginning. But we wanted to do this after interpod anti-affinity, after even pod spreading becomes beta. Because right now we cannot really make that change and remove anti-affinity because we don't have any alternative solution for it. But once we have even pod spreading in beta, then users can start using it. It'll be enabled by default, and then we can gradually phase interpod anti-affinity out. Does this answer your question, Aldo?
Yes. I just have a couple of follow-ups on implementation details. So I don't think we have started to do even pod spreading within the framework yet, but there is already some ongoing work on the pod affinity and anti-affinity. So my question is, if there's this data structure to share data, where should this be calculated? Is it during pre-filter?
Yeah, maybe.
Yes. So if basically, even let's focus on even pod spreading. It applies to other similar features as well. So let's say that you want to pre-process some information for even pod spreading. So even pod spreading has 2 versions, if you will. One is the required one, or hard spreading. The other one is the I guess what is the other version, like preferred? I guess that's what we call it. So which is like soft spreading. So for the required version, you probably want to put this information in pre-filtered plugins, and if there is some other information that is required only for scoring, you probably want to put this in like post-filter plugins, while doing the pre-processing in post-filter plugins.
Right. The only caveat here is that priorities still depend on the whole cluster and not just the filter nodes in some of the cases. So
yes,
just need to be careful in that sense.
So don't we have access to all the nodes? In
Yes.
filter, we definitely do have access to all the nodes. But my assumption is that even in post filter, we have access to nodes, right?
Yeah, I think so. I think Draven mentioned that we can use the framework handle to get the snapshot info so that we can get all the nodes info.
Yeah. Also, if there is a need, we can also put other API in the framework handle, like for example a node tree or whatever is needed. if we need something more to actually give you all the nodes, not only the filtered ones.
Okay.
Some side comment is that it's not only the predicates may need the extra nodes information, that priority can also need extra information like even path spread. Because if you're running on your topology is on a zone, right? And you have some paths have some nodes has matching paths on the nodes which has failed the previous predicates, but those matching paths should also be counted. So just as a comment that these other nodes.
Correct. That is right. Right. Absolutely. So you need to have access to everything. But you know, the reason that actually we have the framework handle is to, of course, thoughtfully add more information about the internal state of the scheduler to that framework handle so that plugins can use it. So initially, actually, we were thinking that you may even expose the whole cache, the whole scheduler cache to plugins, which we may actually need to do. But whatever we do, we should probably think about having a specific API and not expose everything. For example, instead of just having a simple pointer in the cache so that all plugins can access the cache and use all the API, we should come up with an interface that exposes only certain functionalities of the cache. For example, read nodes or get nodes or get pods on a node, or things of that sort, so that the whole cache is not exposed. We always have a protocol, which is that interface that I'm talking about, just a smaller interface, and only add more functionality to this interface based on real needs and after considering all the options.
Sounds good.
Yeah, all right. So yes, I believe that. So the second item, although is yours as well, I think. Is this something that we discussed, or this is actually something else? It's the filter plugin, the support preemption. So
yeah, just a follow up on the already open bug. I think pretty much everyone agrees that we should go with option, what we were calling option 1, which is let the plugin decide whether or not preemption should be attempted.
Yes.
But the only downside, or the only counter argument was there was the worry of the concern of having this extra status code. So I came up with a couple of different options, and I would like to hear the feedback on them. So one of my options is to just add an extra return parameter to the filter plugin, or had an extra status field in the status structure instead of having an extra status code.
Yeah. So I believe we discussed this. I was not super. I wasn't a huge fan of actually adding another field to the status, because I felt like if we just add a status, it's going to be meaningful only for this particular code. Status code can be a few options, a few different values already. And in the future, that list might grow. This particular field is meaningful only in the case that the code is unschedulable. That's why I was not super happy about this, and I felt like that interface might become a little confusing. That's my only minor concern. Another option, of course, is to add a function to status. Today we have something like is success in the status that provides, that actually checks two different values. One is that the whole thing is nil. The other one is the status code is set to success, and it returns true in both cases. Similarly, I thought we could add a function to status, which is called is unschedulable, and it could return true in both cases, both basically for unschedulable and unschedulable, unrecoverable, or something like that. Unresolvable that we were thinking about. That's another option. I actually like this option better than anything else, but I don't know. That's my personal preference. I cannot really very strongly say why I don't like the other options.
Okay, so I think my only concern with this status option is that it's only valid for one particular filter or one particular extension point, and not the rest. So
You mean the function for a status?
no, the status code, because now there's two unschedulable options.
Mm-hmm.
One of them is only makes sense for one of the extension points. So in that regard, I liked more the idea that Wei suggested of having flags.
I mean, generally speaking, unschedulable is limited to filter plugins, right? We don't expect score plugins to mark a pod as unschedulable. So regardless, this particular like these two like unschedulable codes are coming from this one extension, in my opinion.
Mm-hmm. Okay. In that sense, so if that's your preference, maybe I guess I would like to have it stated in the issue. Maybe some thoughts on the other two options that I gave.
Yeah, definitely. I mean, please list them, and then if other people have other ideas, they can also add them, or if they prefer one or the other options, we can actually see what their arguments are, and then based on all the feedback, we can decide which one to take.
All right. Then I assume next SIG, if we have all the input, we can take a simple vote or something like that.
Yeah.
Okay, sounds good. Well, the options are listed already there. I don't think I have any other.
Okay.
Yeah.
Sure. I will also take another look. All right. So, is there any other question or comments about these topics? All right. Let's move on to the third item, which is related to a question that Wei has raised, and that's how to treat tainted node for even pod spreading. So basically, the idea here is that when we are spreading pods among failure domains, let's say 2 zones, now in each zone there are some nodes, let's say that we are spreading pods among nodes. There are some tainted nodes among the nodes that we are considering. Now, how to treat these nodes, because obviously the number of pods on some of these tainted nodes may be different, and we don't want to schedule more pods on the tainted nodes. So should we not schedule any more pods on any other nodes in that case? So that's a very good question. In fact, I believe if we don't schedule pods, it'll be surprising for users. So if we have like required spreading, a user, let's say some users puts required spreading, and the spreading domain is node. Now a node in the cluster gets tainted, so the number of pods on that node is going to be different in that case, or maybe exceeds the max skew that we have. In that case, no other pods that belong to the same like even pod spreading selector can be scheduled in the cluster. So I think this is going to surprise users. What is your take, Wei? What do you think about that?
Yeah, so yeah, it's an interesting question. So right now, the alpha implementation is that we do respect the team. So as long as it's matched the node selector or node affinity, so we count that as a valid node. So that means we take it into consideration that how many matching paths on that tented node. We just suppose that the incoming node doesn't have the corresponding toleration. So right now, I just categorize different taints, right? We have user-specified taints. We have system-generated taints. So it's, if my opinion or sort of a preference is that we might be able to provide the option for user to say that if it's a system-generated preference and it's sort of like unschedulable, maybe it's caused by a kube control drain command or any other command. So if that is the case, maybe we can discard that tented node. But it's a very, very initial thought on this.
Yeah.
I need more users' feedback and how they view this question and how their workloads looks like. Yeah.
That's a fair point. I think particularly the no execute taints, especially. So how about this? You know, we have these we have these no execute taints that we place on certain nodes to basically drain them. Those are definitely gonna, if we basically don't process these taints and count all of those nodes towards like spreading requirements, they are gonna definitely cause some surprises, I would say, because some of the no execute taints are automatically added by our controllers.
Yes.
For example, a node becomes unhealthy and it's tainted, and then suddenly that tainting causes no other pods in the cluster to get scheduled, or at least pods that have some even pod spreading requirements to not get scheduled. So that is, I think something we should avoid. One option, in my opinion, is to consider automatic taints, basically the taints that are automatically added to nodes as a result of node conditions. Node controller adds these taints automatically when certain node conditions exist. At least we should probably take out or remove the nodes that are tainted automatically based on their conditions from our spreading calculations.
Yeah, unless the incoming path already has the toleration. For example.
Yeah, I mean, if it has the toleration, you should probably, yeah, you're right. In that case, we should not take them out.
Yeah.
I think I would say that the problem is more general, because we can have several filters that could cause that a node has 0 pods of the spreading topology or the labels, and that would cause the minimum skew to be 0, and then we can calculate the max skew appropriately.
Well, we don't have any minimum skew. What do you mean by minimum skew?
Sorry,
minimum match.
Minimum match.
Yes, minimum match such that the skew is big because the minimum match is 0.
Right. Basically, the skew exceeds max skew.
Yes.
Yeah.
And that's going to happen for affinity. That's going to happen with tainted nodes, and could happen with other.
I mean, Affinity is not a problem, because if someone puts some wrong configuration to ensure that some of the pods do not land in certain areas, then they should be responsible for their pod configs. But taint is a little bit out of their control, right? So, for example, if a node is tainted because it's unhealthy in a cluster, they cannot do anything about it. So just suddenly a node becomes unhealthy, and all of their new pods will not get to scheduled because there is an unhealthy node in the cluster. And whatever they put in their configuration is not going to help, unless they go and like add something in their configuration to tolerate an unhealthy node, which is undesirable as well. So so that's slightly different than adding a config, something like an anti-affinity that causes that conflicts with even pod spreading.
Yeah, although the case you mentioned is a little bit like the user-defined taint. For that case, we don't care about that because it's a user behavior, right? User specify the affinity.
Yeah. I think that's slightly better. That's slightly better. Although, I mean, of course, we can assume that a user that adds a taint to a node has enough permission in the cluster to do so. So in that case, a user which has like cluster admin privileges can be held responsible for their actions, so it's fine. But some of these particular taints which are added as a result of a node condition are a little bit more problematic because they are added automatically and they are added out of control of pretty much all users. Suddenly a node is unresponsive and it gets tainted and all these problems.
I just think that it would still be pretty common to have tainted nodes that are set by the user. I'm just saying that I don't think we should not consider the tainted nodes, user tainted nodes, as we are considering the system ones. I think we should consider all of them.
You mean as long as a node is tainted, we should take it out of our equation when we are calculating spread?
I would say so. But
no,
again,
I think my preference is a little like Bobby's. We should only care about the system-generated taints, I think. We shouldn't care about the user's taints. That's my opinion.
And one more question: should we care about these tainted nodes only when we are spreading among nodes, or?
That's a good question. I would say, yeah, I bring this question. I think in practical, it will mostly affect the use case that they put the spread constraint on the topology with node. Right. If you put onto the zone, it will be much better because you have multiple nodes per one zone, so you can maybe find another node to put there.
Yeah, but that will still affect in small clusters.
Yeah, you're right.
I mean, but the problem is that if we don't count the tainted nodes when you're spreading, let's say, in a larger group of nodes, for example, in a zone, then it can also cause some other kind of confusion, right? So you see that, okay, if a zone has a small, let's say you have a bunch of zones, each one of them has a small number of nodes, some of these nodes are tainted. If you just ignore those tainted nodes in one zone, then it may look to the user that the balance is very much off because you're not counting those tainted nodes. And the user probably expects everything to be counted when you're thinking about the spreading among zones. So I think, I mean, this is definitely something that bugs me quite a bit because we're adding a hack after another. We are looking at like, oh, spreading is only on node. So we should look at the label, particular label look for the spreading topology key. And if it is a node, then we go and look at taints. And for taints, we don't look at all taints, we look at only certain taints. And if in the future we decide to add a new automatic taint after a condition, someone has to go and change this code in the scheduler as well to not consider this other thing. So it's a lot of horrible hacks in the code, which is not great.
Yeah, I think the ideal case is that once this issue is opened and no user is concerned with this issue, they are happy with current behavior, then we don't bother to change the implementation. Yeah, let's see how users say. Let's see how users say.
Okay. Okay. Yeah.
Mm-hmm. I have the feeling that implementation-wise, this should be like the plugins should share some information in the metadata, and then in the event pod spreading plugin configuration, we can set which metadata components or data we want to use to consider or not consider a node.
Yeah, we can do that. I mean, but regardless, eventually we have to basically build some default behavior, which 99% of our users are going to use, and the API, as we considered and talked about, is going to be confusing. So if we decide to go and ignore taints, I would probably ignore taints only when spreading is among nodes. I would probably go and consider ignoring all kinds of taints for the reasons that I actually talked about.
When you say ignoring, you say ignoring the whole node for calculations, right?
Yeah.
Yes.
Yeah, that's what I would agree to as well, just for simplicity.
Yeah.
Just like we are doing already for Affinity.
Yeah, let's think about this, and we can discuss this further both in the GitHub. If any one of us come up with a better idea or better solution for this, please share them. And also we can rediscuss this in the next week meeting. I don't know if Abdullah is going to be here. Probably he's not. I believe he's going to be on vacation next week as well. Yeah. But anyway, let's bring this up in our next meeting again. What do you think, Wei? Are you in a huge hurry to finalize this?
No, I just open this for brainstorming, and in a new, at least before beta, we don't need any code change.
Yeah.
Current behavior. No.
Yeah. Yeah. Exactly. Okay. Sounds good. Let's think about this and discuss this further. Hopefully, we will find a better idea for addressing this problem. And the last thing that I wanted to say is that we actually decided to consider all static pods as critical pods. This is something that maybe I have talked about last week as well. And now that PR for considering all the static pods is merged. So in 1.16 and newer versions in the future, all static pods are considered as critical pods. This means that they are not going to get rejected by admission logic of kubelet, even if the node does not have enough resources. Also, it means that these pods are, let's see, these pods are gonna be there on the nodes even if the node runs out of resources and other high priority pods exist in the cluster. So these pods are not gonna get preempted. That's all, and we are 8 minutes over time. I apologize for making the meeting so long. We had some important topics to discuss this week. Thank you very much for attending. If there is any other questions, question that can be answered quickly, please go ahead and say those. Otherwise, we can end the meeting. All right. Thank you very much for attending. See some of you folks next week. Bye.
Yeah, bye. See you next week.